Hi folks, welcome to the second video on tree diagrams. So I wanted to take the time to do a little bit more of a complicated example. And again, we're just going to go back to the classic cards because I think it's nice to know about a deck of cards, okay? So in a standard deck, there are 52 cards. 12 of the cards are face cards and 40 of the cards are not face cards. And we're going to draw two cards one at a time. But what's different in this one is we're going to go without replacement. So like we're going to pick a card, we're going to look at it, and we're not putting it back in the deck, okay? And our tree diagram is already labeled with all the possibilities. And so let's kind of break this down for ourselves, okay? So in the first draw, we can either have a face card or a number card. And because there's still 52 cards in the deck, our face card probability is 12 over 52, and our number card probability is 40 out of 52. Now, after we draw a face card, we could draw a face card or we could draw a number card. And one thing you might notice here is that the denominator here is really 51. The reason why it's 51 now is because we took a card out and we didn't put it back, okay? And so our probability of getting a face card a second time is 11 out of 52 because we already took out a face card and we already took out a card, so 11 instead of 12 and 51 instead of 52. And because we're drawing both of them, we multiply them together to get that probability of drawing a face card and then a face card, okay? And we do the same thing if we draw a face card and then a number card. We take 52 and we subtract 1 because it's 51. We took out a card and we didn't put it back. But there are 40 number cards to choose from, so this is still 40. And when we multiply 40 and our 12, we end up with 480. And when we multiply our denominators, we end up with 2652. Okay? The same thing is true. We order when we pick a number card first and then a face card, we have this probability. And then if we draw a number and then a number, that's the most common one, the highest frequency or the highest probability of 1560 over 2652. And again, we got that numerator because we took 40 times 39 to get 1560. Okay, so I think we can start to see like why a tree diagram can be so helpful in figuring out probabilities of things that happen at the same time, right? Or like one after the other, and they depend on each other. And so let's take a look at the questions we're being asked, all right? So part A says find the probability of a face card and then a number card. So probability of a face card and then a number card. Oops. Or a number card and then a face card. And I want to write this in sort of a different way to help us understand what it really means. This really means we find the probability of finding a face and then a number and adding it. So the or is really like we're adding these two cases, probability of a number card and then a face card. And we don't have a ton of calculations to do. The work is really in setting up that probability. We can just take the probabilities that they found for us and add them together, okay? So 480 over 2652 plus 480 over 2652, okay? And so when we do that, we get 480 over 2652 plus 480 over 2652. And just a friendly reminder, when we add our fractions, we add the tops, but we keep the bottoms the same. So we get 960 over 2652. If we put this into the calculator in our decimal form, we get 0.362. Okay, you have about a 36% chance of getting a face and then a number, or a number and then a face. Okay. All right. For part B, find n given f. All right, so part B, find the probability of n given f. And so I want to remind us of a formula that we learned earlier in the chapter, right? The probability of something given something else is the probability of those two things happening together over the probability of that second thing already happening. And so we can use this table to help us find that. The probability of getting a number and a face, all right, is going to be 480 over 2652, 480 over 2652. And then the probability of getting a face card is 12 out of 52. And if we put this into our calculators, we should get about 40 over 51 or 0.7843. Okay. But some of us might notice 40 over 51. Well, Judy, that's the same as this 40 over 51. Okay. So let's go back and think about what this question is really asking. It says find the probability that you get a number card after you've already drawn a face card. That's the same thing as saying you've drawn a face card and now you're going to draw a number card. What's the probability of that? So you could have just said, oh, I followed the tree diagram and I got 40 over 51. Okay. It's not a coincidence. It's meant to be that way. So there's sort of ways that you can reason through your tree diagram, or you can always just follow the formula. Okay. All right, let's take a look at C. Find at most the probability of at most one face card. So what that means is I want to think about the probability of getting a number and a number. Okay. That's no face cards. Or the probability of getting a face and then a number, or the probability of getting a number and then a face, right? In all of these cases, I get 0 or 1 face card. So basically, I've excluded the case where I have 2 face cards. So another way for us to think about that is like 1, which is the total probability, like 100%, minus the probability of getting 2 faces. Okay? So I'll leave that up to you, whether you want to add these 3 to get this side over here, or if you want to do 1 minus this and get the 1 minus the probability of a face times a face. Okay? But either way that you do that, you should end up with 0.9502. So it's a pretty big chance, 95% chance that you're going to get no face cards or only 1 face card. Okay. All right, let's think about part D. Part D says the probability of at least 1 face card. So that means if I look back at this tree diagram, I don't want the case where there's no face cards. I want to have at least 1. So 1 face card in either order, or I happen to draw both face cards. Okay. So if we set up a similar formula, I could think the probability of 2 faces plus the probability of a face first and then a number, plus the probability of a number and then a face. Or if I want to shortcut it, I could just say 1 minus the probability that I get no faces, only 2 number cards. And either way I do this, I should end up with 0.4118. Okay. And again, we're just using our calculators to add these and then turn them into decimal form. Okay. So let me get this all on one page for you, but hopefully it was helpful to see a more complicated example here and bringing back some of the things we learned earlier in the chapter, but let me know if you have any questions.